Hello, this is the luckiest maths teacher in the world. Today we look at how to multiply together a row matrix and a column matrix. First, we're just going to take a look at how we multiply matrices in general. So I'm going to say, let's say I have one matrix A and one matrix B. So if A is an m by n matrix, so remember the first number is how many rows, and the second number is how many columns. B has to be n by p. So again, rows by columns. Now you're probably thinking, well, what does that mean? So what I'm saying is if you want to multiply two matrices together, these two middle numbers have to be the same. The number of columns in the first matrix has to be equal to the number of rows in the second matrix. And this is just because of the way we define multiplication for matrices. So if these two are not equal, you can't multiply the two matrices together. So please don't think that if I give you any two matrices, you can always multiply them together. Often you cannot. So in addition to this, matrix multiplication is not commutative. So what that means is the order of multiplication does matter. So if you multiply A by B, that won't necessarily give you the same answer as if you multiply B by A. Moreover, sometimes the order will determine whether or not you can do it. So as an example, if A is a 2 by 2 matrix and B is a 3 by 2 matrix, I can't multiply A and B. So A times B doesn't exist. But I can multiply B by A. Because if I try and multiply B by A, 3 by 2, by a 2 by 2, these two numbers are equal and you can do it. So not only does the order of multiplication give you a different answer sometimes, but sometimes if you try to multiply in a certain order, you won't actually be able to do it. So now let's look at row matrix by a column matrix. So you know that a row matrix is just a matrix with one row. So let's say I'm going to define matrix A by 3, 2, -4. Now we know that a column matrix, so I'm going to make B a column matrix, is one with one column. So let's say 4, -1, and 0. So in this example, A is 1 row by 3 columns. B is 3 rows by 1 column. So because these two numbers are equal, I can multiply A and B together. So you can multiply a row matrix by a column matrix as long as both of them have the same number of elements. See how both of these have 3 elements? I will be able to multiply them together. Now when I write down the sizes, I told you before that these two numbers must be equal, otherwise you can't do the multiplication. The other two numbers give you the size of the resulting matrix. So A times B will be a 1 by 1 matrix. And that will work for all the questions we do in this lesson. Anytime you can multiply a row matrix by a column matrix, the resulting matrix is always 1 by 1. So please make sure you understand that a 1 by 1 matrix is different from a scalar. So let's look at how we would actually do it. So when we're multiplying two together, we follow the rule of across by down. So we go across the first matrix and down the other matrix. So let's actually go ahead and do this. 3, 2, -4 multiplied by 4, -1, 0. So I think it's always helpful if you know what the resulting matrix will be, you know its size. So this is just going to be 1 by 1. So across by down means we go across by down. What that means is we pair up every element in A with one in B. So we pair these two together, the first elements, and we multiply them together. Then we pair the next two elements together and we multiply them together. And same with the third ones. And what you do is you actually add all of these up. So the answer to this multiplied by this will be 3 by 4, which is 12. 2 times -1 is -2. And then negative 4 times 0 is just 0. So it will be 12 minus 2, which is just the matrix with one entry, 10. So because we go across by down, that's why the number of columns in the first one has to equal the number of rows in the second one. Because the number of columns here equaling the number of rows here means that each element can actually be paired up. If I had one more entry here, like a 5, it would have no pair in the first matrix. So that's why we need to have the two middle numbers being equal. All right, I'll do a couple more examples. So let's say I have the matrix, I'm going to call it C this time, minus 5, 2, minus 9, 1, and the matrix D is going to be 4, 3. So let's say I want to calculate CD. So C is a 4-column matrix and 1 row. So it's 1 by 4. We always write the rows first. D has 2 rows and 1 column. These two numbers are not equal. So I cannot do CD in that case. So let's say F is going to be the matrix 4, negative 1, 2, 3, and G will be the matrix 10, 9, negative 2, 0. So these two can be multiplied together because this has 4 elements and this has 4 elements, which is what I told you before. In other words, this first matrix here is a 1 by 4. And G is a 4 by 1 matrix. These two numbers are equal, so I can multiply F by G, and the resulting matrix will be 1 by 1. So, FG across by down, it will be a matrix with 1 element, so it'll be 4 times 10, plus negative 1 by 9, plus 2 by negative 2, plus 3 by 0. So again, we're pairing up elements, multiplying them together, and adding up all our answers. So it's 40 minus 9 minus 4 plus 0, which just gives us the number 27. Okay, I hope you enjoyed this video and got something out of it. Thank you for watching. This has been the luckiest maths teacher in the world. Have a great day.